Hello guys, in the last video I discussed about the data structures. Now we're gonna discuss about how the data in the real world is mapped to data in the memory. So we will be having certain data that is in real life, and we're gonna map this data into the computer memory. Here we have memory. Now we're gonna see how this data is actually converted to memory cells and how this data goes into the memory cell. Like in our real world, we have a lot of data. People are walking, they're walking data, distance, and everything. But we need to know how this data gonna map into the real memory data. And now I'm gonna take an example from the Donald Knuth's book Art of Computer Programming, in which he described this mapping by using a quite good example, which of course you all are of, is the cards, that the playing cards we usually play. He said that if we have a pile of cards, okay, let me draw this first. The example is quite clear. It will not be very difficult to understand, so don't worry. We have three cards: 1, 2, and 3. Three of these cards are different. What does this mean? That one card is of 2 of diamonds, one card is of 3 of spade, oh sorry, it's club, and the other card is of which we will which one we're gonna take, maybe 10 of say say diamond as well. Okay, so we have 3 cards. This is their data. How this data will be mapped into memory? Here we have memory. We have 3 cards, and the one thing that I really want you to understand is these cards are compiled like this one. This card, then this card, then next card, then next card, then next card. It's like a compile of the cards. So I will be saying this is my first card, this is my second card, this is my last, that is third card. So what is it? This is first one, 2 of diamond, this is second one, 3 of club, this is last one, 10 of diamond. So this is how I have put my 3 cards in the real world. Now need to convert this data into the real memory. And as I have already discussed in the last few videos about the memory cells in mix. So how we describe the memory cells? Memory cells in mix architecture, we said that there will be something like this with a plus or minus sign, and here will be 5 bytes of data will be stored. 1, 2, 3, 4, 5. So here we will be storing 5 bytes of data. Now how we gonna convert this data to this? This is quite complicated question, which is quite interesting as well, because this is real world, this is ones and zeros world. So how we gonna convert this real world into ones and zeros world? Let's dive into it. So firstly, we will be saying that we will be representing this data in this kind of format, trying to represent. Let's try to represent it. What we can do is we can have a plus, we can put some tag over in the first byte, then we can put suit of the card like spade or whatever it is, then we can give it some rank. I will be discussing what does it mean, and then we can give it link. Okay, So we can say plus or minus, whatever we want to use. Just for the sake of simplicity, let's use plus only. And tag, what does this mean? That we will be saying 0 or 1 over here. Now what is the meaning of 0? Face downside, face downside. It means that the card, if this is the face of the card, then card is like this on the pile, okay, and one is means upside face. Okay, now the suit is means either it's club, diamond, or whatever. For like I just gonna say 1 for club, 2 for diamond, 3 for spade, and 4 for what's the other one? Let me see what's the other one. Other one is a hearts. Okay, so we will be having suit, tag, rank, and link. What does this rank mean? Rank is the number, like 1, either it's 1 of club, 2 of club, 3 of club, up to 13. The kings and queens are also like 11 is J, 12 is Q, like that. So rank will be any number between 1 and 13. And what is the link? Now link will be some sort of number which will link will refer to memory of next card in the pile. What it is? Memory location of next card in memory. Memory location of next card in pile. Memory location of next card in pile. So what does this mean? That we have one card, this one, second card is this one. When we represent this card, the first one, into the memory, we will be saying like this, we will be linking this to the next card, and what will be the link of in the location of this card will be the location of the next card. It is quite confusing, but I will be explaining it further on when I will be transforming these cards into these form, so that you can better understand. So let's try to change this card into this format. Let's see. So we will be transforming our first card into this format, and then this format, this is what? This is memory. This is memory format. One thing is a point to be noted is these numbers will not be represented as 1, 2, 3, 4. These will be represented either in binary form or hexadecimal form. Like link, this is a location. Location is represented in hexadecimal form, and the other things like club or diamond or whatever it is, these will be represented in binary in the memory location. So it's quite clear. Now let's try. Okay, so here we will be having plus, we will be having a tag. Now if I put 1 over here, what does this mean? That this is the face of the card, and like this it's in the pile. Okay, next is suit. What's its suit? This is diamond, so here it will be 2. What is its rank? Rank means number, that is 2. And here we will be left 1 byte. These cells are bytes. We will as I have already discussed in my last few lectures, these are the bytes of the data, 5 bytes of data. Okay, so we are left with 2 bytes. What we will be putting in 2 bytes? In 2 bytes we will be putting the location, link. Here we will be putting link, and link is what? It is a memory location of next card in the pile. Okay, so let's go to, now we have represented first card. How we will be how this This card will be translated into the memory cells. Now we have represented this. Suppose that our first card is lying over here. This is our first card. We can similarly put second card over here. We can put third card over here. Okay, this is how we can translate real world data into some data structure inside the memory. Now the key thing that will come to the mind of a student is, how are you gonna tell the memory that this first cell is tag, this suit is the name of the card, either club, diamond or whatever, this is the rank. How are you gonna tell the memory that, hey memory, go to this location, uh, like let me redraw a memory structure to better explain it. So how are you gonna tell the memory, this is my memory, I have 6 cells in it, first is plus, suppose. How are you going to tell the memory that, hey memory, go to this location, and I am creating a data structure where I will be putting this card, I want to put this card here, and I will be creating a data structure, but not, this will be tag, this will be suit, this will be rank, and these two will be links. These will be done by the either C++ or whatever language we will be using. When in higher level language we define a data structure, we also define how we will be accessing that data structure and what are the things that we will be putting in that data structure. So if we define this as an array, we say that array, let's say we just define an array either in C++ or Java and name it as array just for the sake of simplicity. This is our array. Then we also define the offsets that, hey, the first location will be my tag, second location will be my rank or whatever, or third location and the fourth location. So in our computer program, when we write the program in C++, we will be having access to these cells individually. So we can say array dot rank, and we can all say that, hey array give me your rank. So it will give you rank, whatever the rank will be, it will take out and put it on a screen that this is the rank. So this is how we create a data structure, put the data inside that and try to access that data. This is quite complicated to be to understand, uh, because at such a lower level of abstraction it is very difficult to understand how the real world data is mapping into the memory and how the different things will work out. Like if we write C++ program, just to take this scenario that we have 3 cards. Suppose that we are designing a game in writing code for a game in C++. So we will be having 3 cards, like we are putting these cards like this, and then we want to represent this in this form. Then it will be quite difficult for us to work at such a low level. So we will be writing the code, and in the code we will be putting these stuff as well, that do this, and then the data will goes to these positions. If we want to access, then we can access that. This is how real world data gets mapped into memory locations. And if we want to just like say this is our first card, like this is our first card, this is our second card, this is our third card. Now if we want to perform any sort of computation on these cards, like we want to just flip the card, that first card, second card, third card, we want to say second card come up, we want to flip it. So what we will be doing at memory level, we will be saying, look, whatever data structure we have at location 2, take it to location 1, and whatever it is at 1, take it to level 2. So what will be happening at memory level, this thing will be going up, these things will be going down. So that's it. That's whatever it will be happening. Now in C++ you define a temporary variable, then put this data structure into that and then change it. That's a higher level stuff, but whatever algorithm applies at the lower level is this. I hope that this will help you to understand how so much data is mapped into the memory cells. Thank you for watching. Please subscribe, like and share. If you find this useful, then check out the other videos in the series. Thank you.